Hi, welcome to the flipped instructional session for Math 08A for Unit 108, Scientific Notation. Our objectives today are to interpret scientific notation, to evaluate numerical expression with exponents, convert very small and very large numbers to scientific notation, and to convert very small and very large numbers from scientific notation to standard form, to compare quantities written in scientific notation. Our vocab for today: power of 10, scientific notation, and standard form. So a power of 10 is any number that can be written in the form 10 to a power. So scientific notation is the big one we're talking about today. And we'll do some examples here to help understand this. But it's a representation of a number as a product of a number that is greater than or equal to 1, but less than or equal to 10, and an integer power of 10. So what that means is, so this is an example of a number in scientific notation, 2.69 times 10 to the 7th power. And so the important part is there can be exactly one number in front of the decimal. It has to be one number. If we have 10.68 times 10 to the 9th, this is not in scientific notation because there's two digits in front of the decimal. Same goes for if we have no digit in front. This is not scientific notation. So we have to have exactly one number in front of the decimal for it to be in scientific notation. The exponents can be positive or negative, but it's only one number in front of the decimal. So that's scientific notation. Standard form is just the regular way we've always been writing numbers. And so we'll find really big numbers today or really small numbers. These are in standard form, and we'll work to put these in scientific notation. So a quick review: which expression has the same value as 4 squared minus 6 times 2? So remember, in our order of operations, parentheses, which we don't have, exponents first. So we do have an exponent. So 4 squared is 16 minus 6 times 2. Now the multiplication, so 16 minus 6 times 2 is 12. Then we can do the addition or subtraction. So we have 4. So now we need to look at this and see. I'm not 100% sure what this means, so we'll cross that one out. So 1 minus 8 to the 0 power. Anything, well, we'll talk about that in a minute. So we still need to do, please excuse my dear inside. So exponents first. So 8 to the 0 power. Anything raised to the 0 power is 1. And 2 squared is 4. So we've done our exponents. There's no multiplication or division, so we do addition and subtraction straight across. So we would do 1 minus 1, which is 0, plus 4, so we get 4. So these actually match up. Let's just work on C just for practice. The first thing we need to do would be the exponent. 4 to the first power is just 4. Then we do multiplication, so 10 minus 6 plus 4. Addition and subtraction left to right. So we do the subtraction first because it comes first. So keep that in mind for this multiplication, division, addition, subtraction. They happen left to right. So 10 minus 6 is 4. So we have 4 plus 4, which is 8. So let's match the scientific notation to the correct standard form. So when we see a positive exponent, so let's take a look at number 1 and number 3. When we have a positive exponent, we make the number bigger. So for 3.8 times 10 to the 7th, this 7 tells us we move the decimal 7 places to the right. So don't just add 7 zeros. That is not how it works. You need to move the decimal. So when we move it around the 8, that's 1 time. So we need to move it 6 more times because we already moved it once. So 1, 2, 3, 4, 5, 6, 7. Fill in your zeros. So we see we have 6 zeros. So this goes with number 1. So this one says we move it 6 times to the right. So again, you got to move it around the 8. So that's 1, 2, 3, 4, 5, 6. Add in our zeros. So this is 5 zeros. So this right here is number 3. Now, when we have a negative number, we make the number smaller. We move the decimal to the left. So again, we start where the decimal is and then we move it over. So we need to move it over 7 times. So 1, 2, 3, 4, 5, 6, 7. There's our decimal. Add in our zeros. So there should be 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. So this is number 2. Here we move the decimal 6 places to the left. So that counts as 1, 2, 3, 4, 5, 6. I made it bigger this time for my zeros. So there's 5 zeros in front. So that goes with number 4. So if it's a positive exponent, we move it to the right. If it's a negative, we move it to the left. And we have to count any numbers we go around as part of our movement. So don't just add in zeros. This says convert 527 billion to scientific notation. So we want to count. I'm writing it really big here so we can move the decimal. The decimal starts over here at the very end. So we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because remember, we need one number in front of the decimal. We moved it 11 times. This number is big. So from here, we want to move the decimal back to the right. So that's a positive 11. Because when we have this 5.27, we want to make it bigger. We want to move this decimal back to the right. So it's a positive 11. 5.27 times 10 to the 11th is scientific notation. If you wrote it 0.527 times 10 to the 12th, this would be incorrect because we don't have a number in front of the decimal. If you wrote it as 527 times 10 to the 9th, this is incorrect because you have too many numbers in front of the decimal. You can only have one number in front of the decimal. So this one is a very small number. So small that I'm not even sure I know how to read. 1, 2, 3, 1, 2. So we need to move the decimal until we have one number in front. So I'm going to make this a 3.91 times 10 to a power. So how many times do I have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. We moved it 9 times. Now, in order to get back to it, we need to move this decimal back to the left. So it's a negative exponent. 3.91 times 10 to the negative 9th. You have to make sure you move this all the way so just the 3 is in the front. So this is an expression that you might see on your calculator. And we see this weird little e and this minus 12. So this means times 10 to the negative 12. That little e. So when you're typing your answers for the part 2 version of the test, you can write it. Sometimes you put a little caret, which means power. You can write it like this, and I'll know that this means times 10. So these are a couple different ways that you can write it on your test. So let's convert this. Is this number going to be bigger, smaller? It's going to be smaller. We need to move the decimal 12 places to the left. So we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to add in 10, 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think I moved it. I think I only counted to 11. So we move at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. 12. For more on this, look at your Class Connect schedule and come to a flipped follow-up where there will be a lesson over this, or you can come to a help lab. In the help lab, there are no lessons, but it is a time to come ask questions when I'm there live in the virtual classroom. Thanks.